Hello, and welcome to this tour of my final project. I previously worked as a mechanical engineer and had a lot of opinions about the user interface design of industrial CAD software. And while I have not come close to fixing all of those or even recreating all of those, I have created a very basic CAD software that I hope to keep expanding from. So let's go ahead and I can hit the space bar to switch from camera mode to mouse mode. I can load in the file that we read from the command line. And we can see we have the little humanoid robot guy. I can tab between his various features. I can use the arrow keys to make him look like that one Jedi from the Star Wars prequels. And I can even make him look like he's waving. And I can also switch back to mouse mode, create a new extrusion that I'm going to shorten and move up and hit the tilde to switch from lengthening and moving in the parallel to the XZ plane, that green lateral plane there, to give him a little duckbill. And then I can, in mouse mode still, I can surround him with some cube friends that I can move around. I can lengthen and do whatever we want. So in addition to that, we can save from files, load from files. We can switch to wireframe mode. We can see the reference planes used to define our model, or hide all planes, or just show the default reference planes. And we can create extrusions. So let's talk briefly about how this geometry is defined. So when we read in from a file, it mimics the internal structure of the various classes and objects. So planes are defined with regards to a point and a normal vector. Sketches are a series of points which make a closed polygon in a counterclockwise direction with respect to a plane. And then extrusions are take the points in a sketch, which again is with respect to a plane, and then extrude perpendicular to the plane a certain distance. So all of the extrusions shown here are nice and simple rectangles, but let's take a look at a more complicated one. So let's take a look at this file. So starting our program again, loading the file we read from the command line, moving around here, and then let's switch to wireframe mode and hide the planes. So we can see that with this more complicated shape, where we have a concave polygon, we need a way of not trying to make a triangle between, for example, this edge, and this edge. So in our code here, we can take a look at, as we process all of the vertices in sequence, we can take a look at two vectors of interest. So if we were trying to see if we can make a triangle here, using this as the center vertex, so from here to here to here, if we look at this vector and take the cross product between them, we can compare the direction of that to the surface normal. And that can tell us if, say, we're driving along this vector, if we need to make a left turn into our shape or a right turn out of our shape with our counterclockwise winding direction. We can do that comparison and see that for this angle, we need to make a right turn, which means that it is a concave angle and we should not try to make a triangle here. But then as we drive along to the next vertex, we then need to make a left turn, and so we are safe to make a triangle here, remove this vertex, and then consider the remaining 4 triangles and keep tessellating. So that is what this function does. This is the tessellate face function that's used within make mesh, within extrusions. And it's one of the more clever parts of implementing this that I was really happy with. There's certainly many, many features that can be added to this that I would like to continue adding. But I am very happy with the framework and editability that currently exists. So thanks for your time and have a wonderful day.